Everyone, sorry for the delay. We are trying to figure out how to make a valid recording, which we didn't succeed last time, and also shut down the noise. No noise now, I hope, but they shut down the voice. So this was a solution for now. I'm not going, as far as I recall today, to use the movies, so it's going to be okay. Hopefully, they will figure it out till next week. I hope. So let's start learning. The topic of today is supervised learning. Today I start to teach the techniques of AI, and supervised learning is the first one which I'm going to cover. Okay, next time he come back to ask him about this also. I have no idea what is going on. So I'm going to cover today 3 topics. I'm going to start by explaining what is supervised learning and what is classification. Then I'm going to say a few words about predictive analytics. And I'm going at the end to of this session.
Maybe we could check another class for next time, another room.
I asked to move the room, but the result, as you can see, is that we are still here. But he's supposed to come back at 4, and he told me that everything is going to work. So I hope that we'll manage till 4. But I'm not sure that this is the problem. Okay.
Yeah.
So let's continue. Okay, and at the end, I'm going to speak about challenges that ones who would like to use classification may face, and I'm going to explain why cabbage sometimes might be a problem. First, I'm going to repeat the slide that I demonstrated last week, and this slide is going to appear again and again in this course. I'm going to explain the difference between supervised and unsupervised learning. Supervised learning, which I'm going to focus on today, meaning that I'm giving the machine object with labels, meaning the ground truth of this task. For instance, the task now is to try to classify between apples and not apples. And I'm going to use an algorithm of supervised learning, which we're going to cover today. I'm going to build a model. And next, I can use the model. When I'm trying to deploy it, I'm going to challenge the machine with an object. And in this case, it's a picture of an apple without the label. And I'm expecting to get the correct label. This is the basic idea of supervised learning, which I'm going to focus today. In contrary to unsupervised learning, in which I just give the machine the object, the machine is going to do some kind of things. In this case, I'm illustrating one of the algorithms or techniques for unsupervised is called clustering, meaning grouping objects together, and I'm going to get some result which I'm going to analyze later. Unsupervised learning, I'm going to cover later on in the course. Now I'm focusing only on these parts. When we speak on supervised learning, there are several terms that we speak about. The first one is classification. Some people will call it categorization, but I'm going to use the term classification. Classification can be used also for predictive analytics, which I'm going to say a few words about today. And the main idea, the main concept of supervised learning is the concept of learning by examples. And what does it mean to learn by example? I'm going to try to illustrate it with this example. you see now on the board 6 animals. If you didn't notice till now, 4 of them are dogs, 2 of them are not. The question to you is, please define to me, taking that you know to differ between dogs and not dogs, what are the differences, or how can you tell what is a dog? Who is volunteering? By the way, don't stay barking because there is no voice, just the image. How can you tell what is a dog and what is not a dog? And by the way, this is a cat and this is a bear.
Maybe a shape nose.
Shape of what?
No,
Nose. Let's see.
the bear.
What actually is the difference between the shape of the nose here and there? And actually, there are different shape of noses, as far as I can see. More ideas?
Certain things. Ears,
Ears,
legs.
legs. What? What about the, you don't see any ears here? Yes, I don't.
But the cat,
Yes,
the cat's ears are different than the dog's. So
easy.
Maybe a few criteria together, like fluffy. and
Fluffy?
straight,
Can you
and
see
we also
fluffy
have
here?
I see the main one that's fluffy.
Well, I will give you the answer. You don't know. Nobody knows. Exactly. Nobody knows to define how one can tell what is a dog. Sounds strange, and this is the reality. This is an example of learning by examples. If you have a little child, in my case it's grandchild, you know that at the beginning they learn, at least in cities in Israel, most of the animals they are going to see are dogs. So we will tell them, this is a dog. This is, in Hebrew, we say hav or how, okay? And once this child will see a cat, probably he will say how, thinking that he's not already to speak, okay? And then we say, no, this is not a dog, this is a cat. And after maybe the 200 cats, finally the genius will say, meow. And then we'll take the genius to the zoo. What will happen? And we'll show him a bear. Probably say, how, right? This is learning by examples. This is exactly the concept of learning by examples. We humans know how to do it, and notice that we don't know in our cognition to say how are we doing it. How do we do it? Okay? So nothing actually sets apart between dogs and cats and a bear. All of them have 4 legs, 2 ears, and a tail. They have all of them have fur. Variety of dog and cat furs is amazing. I'll show you a picture here in a minute. There are dogs in many different shapes and sizes. Little dogs, very large dogs. And still we know that those are dogs. By the way, I didn't use the colors because if you notice, 3 of the animals were silhouettes. And still we know that this is a dog. Okay? And this is because we saw so many examples of dogs in our life, so we can recognize it. And again, look at those cute puppies, different shapes, different colors. And still, all of them, we know to tell that they are dogs. Okay? So if we ask ourselves, what are the features, what are the attributes, we don't know. There are many other cases. For instance, how can you tell your friend's face? You don't know. Okay? You just know him. Questions till now? So, classification is the task of identifying to which group a new object belongs, and the groups are defined or predefined by examples, which are sets of labeled samples. This is the meaning of labeling. Okay, this is the meaning that we are putting labels on things that we know their answer, and we have training data sets that contains objects with known class membership, meaning known labels. As I showed you at the beginning, apple, not apple. Okay, so the concept here is learning by examples. Another illustration for what is classification. Let's say that I would like to classify animals to 4 classes: insects, fish, birds, and mammals. Okay? So I need to give examples for each of these classes. And now, if somebody will challenge me, where should I put the bear? I should be able to say here. Okay? So basically, biology, or the tree of life of biology, is a good example for classification. Now, it sounds easy, but it's not. This is the platypus. Okay? It's an actual animal. It's an egg-laying mammal. So if we would try to classify between, let's say, birds and mammals, well, mammals have males, well, the females. Birds lay eggs. But this creature has both. So what it is? It's a mammal? Is it a bird? Actually, the first time that it was found in Australia, this creature lives only in Australia. In 1798, it was catched and sent back to Britain by the UK people, and they thought the biologist that got it was convinced that this is a hoax, okay? Because it actually looks like an animal that was sawed, somebody that sawed the duck beak with the animal or body of beaver, okay? But this is an actual animal, okay? But by the way, the poisoning one, has poisoning stain, only the males. Okay, so nowadays we believe that this is a mammal, although it lays eggs. Okay, so classification seems to us very easy, but it's not, and I'm going to demonstrate today that why. So back to the slide, trying to define what is classification. So we said those are the definitions, and the way that I know to do the task is based on a particular set of object, feature, or attributes. What are features? Features are specific attributes I put on each object. For instance, I would like to collect features for animals in order to classify them later on to mammals, etc., etc. So I say that the grizzly bear, its main color is brown. This is one feature. Number of legs, second feature. Number of wings, and whether it has a tail or not. So I have here 4 features that describe each of the objects. Okay. In this case, I just put a label of the name of the animal. I need also to add, let's say this is a mammal. The black widow is a spider. The stork is a bird, etc., etc. Okay. Questions? Now, there are 2 ways to go in classification. One of them is binary classification, meaning only 2 groups. Usually it's yes or no, like I started with. Apples, no apples. Or I can do multi-class classification, and then I'm going to have several groups. Okay? Apples, bananas, oranges, etc., etc. Or as I showed you with the animals. So if we get back to this slide that I started with, these are the object. Here I need to define what are the attributes. Let's say I'm going to say something about the color and the shape. and then I'm going to teach it to distinguish between examples of apples and examples of fruit which are not apples. Then I'm going to use an algorithm, which I'm going to speak in a minute, and I'm going to build, as I said, a model. And once I have a model, I'm going to challenge it with a new example without the label and expect it to return the label. Okay? Questions? Yes.
How can you do it, for example, with orange? Because orange can be orange, it can be a color, it can be like so many.
No, I'm talking only currently on the image. Okay?
Okay.
If you said about the word orange, once I'm going to cover the concept of text analysis, then we are going to speak about ambiguity, which is your question. But for now, just the image. Okay? More questions? Okay. So I need to collect samples. I need to label them. I have the pictures. Now I label them. As I said, if you recall, this was a bear. Now I said it's a mammal, and this is a spider, and this is a bird, a reptile, an insect. And of course, I cannot do with only 5 examples. I need to collect plenty of them. How much? How many? Hundreds of thousands, if not millions. Maybe even more. Depends on the task. Okay, I need many examples.
Many rows or many columns or both? Because you added all,
For now, we are speaking only of the rows, many rows.
you need also many columns.
We are going to speak later in the course about the columns, but for now, I just mentioned the rows. Okay. Now I'm going to use an algorithm, one of the algorithm of classification, which I'm going to show you today. I'm going to train, and we'll see in a minute what does it mean. I need to use those examples in order to train. Afterwards, the algorithm is going to create a model, and I'm going to define what is a model. And then I need to test my model. Now, if I would like to test my result, test my model, then I have to be clever and split my examples beforehand for examples which I'm going to use for training and examples which I'm going to use for testing. Why? Consider the example that I'm going to illustrate now. Let's say that you have a multiple choice exam, and you know that there are going to be 20 questions there, and I'm going to give you in before the exam 100 examples of questions, and I'm going to tell you that the 20 that I'm going to pick, I'm going to be from within those 100. Then this is not learning, this is copying. Because all you need to know is to learn those 100, write down the answers, and then that's it, right? So if I'm going to use the same example for training and for testing, I'm not really going to test whether this machine learned, just know how to copy or to give me back the knowledge that I gave it. Okay, so I need to take some examples, many of them for training, and then some of them for testing. Questions about this? Now, after I did the testing, sometimes I'm going to get good results, sometimes I'm not. I'm going to dedicate a class to discuss how can you evaluate the results, but for now, let's say everything is fine. If not, I'm going to go back to the algorithm, maybe change it, maybe do some other stuff, etc., etc. Let's say that everything works fine, everything is okay. I can now go on and deploy. Deploy means that now I'm going to give the model, I'm going to challenge it with new object without the label. Okay? And I expect it to get the labels. And of course, I expect to get the correct labels. Otherwise, why did I bother? Questions? Okay, now let's start to speak about why this can work and what are possible methods to classify. Okay? Just a moment. So there is an assumption that everything in the world can be represented by mathematical functions. This is true because in computers, basically we have numbers. Computers know to understand only zeros and ones, and we can represent almost everything that we know in computers. Once we have the numbers, we can try to think about mathematical function to do something with those numbers. I'm going to give you a better example when we are going to speak about images, but for now, this is just a statement. And then I'm going to use both statistics and another topic in mathematics, which is called numerical analysis. And this field in mathematics is about approximation of functions. It will be better to understand this by using an example. Now let's say that we have now one feature, only one feature, and I'm going to call it X, which is, probably you know, what is called the independent variable. And I have the label, which is Y, the dependent variable. Okay? Now, of course, most of the time, I'm going to use more than one feature. Sometimes I'm going to use thousands of features. But I can demonstrate only 2D or maybe 3D. Okay? So I'm going to use most of the time either one or two features, no more than this, when I'm going to illustrate. I will have problem to try to illustrate 100 animations. So we have now samples. In this case, samples are those points. Those are points that I know their feature, which is numeric, a number, and I know their label. So let's say I would like to know about this point. So let's say this is the number 20, this is the feature, and I'm going to ask myself, what is the label? It's 10. Okay? Basically, a function is a combination of a feature and the label. Now, next, I would like to try to model what is going on here, because I have only examples, right? So I can try to model it maybe like this. This is approximation of the function. And by drawing this line, I'm building a model of what is going on here. Why this is useful? Because I can ask myself now, what is going to happen in 19? If I have the feature 19, what would be the label of it? And I can answer it by using my model, let's say 8. So by getting examples, drawing some function, of course, I can think about infinite number of lines that I can draw here, right? But let's say I think this is the best one I can draw. This is a model. And the model now can predict what is going to happen here. Although I don't have information about it. I don't have examples. Questions about this?
Very complicated.
Very complicated? So I repeat. In mathematics, we know that we can draw functions, okay? Function meaning that I have a number and I have, which is statistics, this is called the independent variable. And then I have the dependent variable. Dependent variable is the Y. So I'm getting a set of examples for which I know what is the X and what is the Y. It's given to me, okay? Till now? Okay. So now I would like to answer, I know the answer for 20, and let's say this is 18. I would like to answer what is going on in 19. But I don't have information because I have this point and that point. So what can I do? I will draw some kind of a line. You can say it's a guess. I can say it's an educated guess. And then if you ask what is going on in 19, I will draw this line and tell you 8. This is the prediction. Okay? That's it.
Right. You say an educated guess, but there are different lines between example 2 and 3.
Right.
So,
There are infinite ones.
so how can you predict by that?
We can't. This is why I call that we are building a model and we need to test it. Okay? And by the way, all of you know something which is very similar to this, and this is regression. What is regression? You have examples of data that you collected, and for each one of them, you know the X value and Y value. And then you draw a line of regression in order to represent them. This is a model. Okay? The same concept. And one can ask again, how can I tell this is the right line? I can. I assume that this is the best I can do. And we are going to speak in a minute. And how can I tell how good or how well did I? I can define the error, right? Because if this is the point, and this is the regression line, I can just measure the distance. And if I'm going to collect all these deviations, I can tell how well I did. That's it. Okay, so the concept that I just explained is exactly the main concept of why can we use regression. Because this line is a model. Let's see this in action. Let's try to make it better. I have no idea. No. No. Yes. Okay, there are very nice people who are doing animation like this, which I'm going to illustrate, that is very useful for lazy lecturers. So, what you can see here, I'm going to just draw points. These are my examples. Okay, these are the examples I have. And now I would like to have a regression. So I'm going to click here. And you see, these are the regression lines. You saw that it moved? I'll do it again, okay? And now I can know exactly what are the errors. Those rectangles are the errors, okay? By the way, notice here, it's called epoch. How many times it took to the machine to get to some kind of equilibrium and say, okay, this is the best result I can achieve. These are the variables. This is the X and this is the Y. No matter what. It's going to work whatever you say. Let's say that this is I don't know, age, and this is how tall are you. Okay? You can say whatever you want. Let's do it.
Explain again.
Epoch is here. I'm going to press it again. You see the epoch? Okay, let's add few lines, a few examples, and let's do it again. And we'll get a different regression line now. Okay, this is the whole idea.
So it's the epoch, how many times?
How many cycles we try? Because I'm going to speak later about what I mean to learn, okay? But this is basically a learning curve. Okay, we start with very bad guess, and then we are trying to do a better until we get to some, let's say, minimal point that we see that I cannot do better. That's.
You take the example of the dog.
Mm-hmm.
You say like, if it's a dog,
No, it's not working like that because those are images. And if you recall, I said that I cannot say attributes. For this, I'm going to explain in the lecture, the next lecture, or maybe I'm going to start today, how you do it with images. Okay?
But in the context, like what comes?
Let's for now stick to numbers. Okay? I have numbers which I know the results, and then I ask myself what is going to happen here. I don't know. So I draw the line and then I can answer. Now, maybe I'm wrong, but this is the best I can do. Sorry, didn't you?
What's the name of this website?
Something. You'll have it in the slides. You just click it as I clicked it and you get it there. Okay? I'll give you the slides. I uploaded the slide already for last lecture to the Moodle. So I'm going to upload this and you just click the button that I just clicked now and you get it. You see here the button?
Yes.
Okay. Okay. Now, regression is a very basic way to try to classify or to predict. It's very simple to use. It does not require any parameter tuning. We'll see later on algorithm that does. It has very good performance. It runs very quickly, as you see. However, it's limited to what is called, in this case, linear, meaning I can only know to draw a line. Of course, there are other type of regression, but the model that I can model is only a specific type of model, and we'll see that there are better ones than this. It is easily affected by outliers, which I'm going to explain in the next slide, and it is subject to overfitting, something which I'm going to discuss later on in this session. This is a very nice, excuse me, need it to work again. This is a very nice example from Wikipedia that you can get the exactly same regression line with totally different set of examples. Here, this is a good example. You see, it seems very reasonable that this model basically represents those dots, okay? Here, well, it doesn't, because it doesn't look linear, right? It looks more like a parabola, if you recall from your high school, okay? So using a linear line is not the best way to go, although this is the best regression line, okay? Here, this is obviously an outlier. And it's very clear that in this case, the line should go here, not there. And the only reason we see this deviation because we try to minimize the error for this point. So if we have a method to identify this and extract them out, we are going to get better results, right? So this is an outlier. Here, for sure, it's nonsense, because basically all those points are here. We get this regression line only because of this point. So regression is a very nice and intuitive method that works. And as you can see, we can get mistakes. And this is a motive that you will hear again and again and again in this class. AI is not perfect. Most of the time, we just try and we get better results or poor results. Okay, so this is very good. All the rest are not. Questions?
So as long as there is less deviation, the model will be more accurate. Is it?
Sorry?
The more there is less deviation, the model is more accurate.
Deviation of what?
Of sample.
What do you mean by deviation? This is deviation, and it's not accurate.
I'm saying the contrary.
Okay. So please repeat.
In this example, the model is less accurate, it's inaccurate.
It is not accurate because of this outlier. Yes. We can do better if we know to take out the outliers.
But then you have a data cleansing algorithm that you simply need to
Yes,
check out.
there are ways to do it, but it just happened. More questions? Okay. Another way to go, there is a totally different algorithm, not a regression. And this is called classification by separation. Now, the algorithm itself is called support vector machines. Why? Historical reasons. But the idea here is that I'm looking at the samples, and in this case, notice that I have X1 and X2, meaning I have two features here. So I'm using the shape as a third dimension. So here I give you the label by the either rectangle or silicon. Okay, so we have two features, X1 and X2, and these are labels of group 1. These are the labels of group 2. Now, what I'm trying to do in this type of algorithm is to draw a line that will separate between regions of group 1 and region of group 2. Again, this is feature 1 and this is feature 2. And obviously, this is not a good model, right? Because I'm striving to get a separation. And here I don't, okay? Here I have only blue rectangles, which is gray. Here I have both circles and rectangles, which is bad. So maybe I can do better, for instance, with this model. Here I do separate between the two groups, as you can see, but I claim that I can do even better. And I try to do by this line. Why this is better? Sorry?
Also the height, it's not
Height?
the difference between the groups.
Yes, this is the idea. Because here we try to make this line as far from both groups. Why? Because recall that my task is to classify new examples, right? So when I'm going to ask myself, this is a new example. Okay, so now my task is to say, does this object belongs to here or to there? Okay, obviously, because of the distance, it probably belongs to here, right? But if I'm going to draw this line, I'm going to give a mistake. If I'm going to draw this line, I'm going to give probably a better result. Okay, so I'm trying to draw the line as far as I can between the groups and still separate between them. And now I know that everything that falls here belongs to this, and everything that falls here belongs to that. Let's see this also in action. Okay, again, now I need to give you examples of two kinds. So there are the blue groups, the red groups and the blue groups. Okay, those are my examples. And now I'm trying to split them, to separate them. And I'm going to use SVM. So I tried to draw this line. As you can see, it did quite a good job. Everything here. Now I'm going to say that all this area belongs to the blue group, and all this area belongs to the red group by drawing this line. Okay? This is the idea. Try to separate, divide and conquer. Questions? Now, one thing that I'm going to say till now, what happens if I have a red one here? You see, this is a problem. But we are going to discuss this later on.
You also call it an outlier in this?
I don't know, maybe. Maybe I can call it an outlier, but maybe it's not. What happens if I have now this group? See now that I have, the line is moving. And still, it's not quite good, right? I have now blue ones in the red region, obviously. So, to sum up with this method, it's the best algorithm when the classes are actually separated, very good separation I can see. It's very effective in high dimension. Of course, I demonstrate only two, but many important or interesting questions have hundreds of dimensions. Outliers have less impact in this method. I'm not going to get to the reason why. It's very slow because finding this line may take a lot of time. And it does not perform well on dataset with overlapping classes, what I just mentioned. And I'm going to get back to this later in this lecture.
Can you go to the previous slide? Can you go back to the previous? Why is there X2 on the y-axis?
Why the what?
Why is there X2 on the y-axis?
Because this is not the y-axis. I said those are two features. The y here is the color. I have here three dimensions. Feature 1, feature 2, and the y label is given by the label either you are a blue rectangle or you are a red spot. Okay. Also, I saw it in the website, the blue group and the red group. More questions? Okay, so let's take 15 minutes break and I'm going to start again at 4:15.
We're really sliding, right? Go down. Go down. So, lasciamo stare. Loro che si va bene, poi più. So, vabbè, vai. Bene. Non sarei sciogna, perché sono tutte le persone jeśli dobrze wytłumaczyłam, ile będę wytłumaczył.
Mas ele não sabe o que é isso. Acho que eu tô lá. Tentar ligar até lá. Eu vou deixar ele. Vou escolher uma outra. Vai estar fazendo. Vai. Não? Você fala espanhol já? Não vai ser uma Uau, deixa eu lá, o que eu vi? Tô. Hã? Tô. Nossa, garrafa, tô. Da minha cidade, você não vai. Sim. I have a question.
Chica? I have a question. I'm still wondering a bit why it's important to use X1 and X2 and how that's different than using X and Y. Is that an important distinction?
No, it's only if you have one dimension of feature or two dimension of features. That's it. I will have problem to illustrate it on boards.
But we were looking at,
We are going to look also on thousands of dimensions.
in the example where we had X1 and X2,
There are two dimensions of features, and label is only one, which is the Y. Okay? So if I have only one feature, I can say X feature, Y label.
right,
If I'm going to demonstrate two features, then X feature, X1, X2, and then I need another way to illustrate to you the label. This is why I use the colors.
so the
Is the Y.
Y.
Yes. Okay. This is the whole idea. Now, if I would like to use three features, I will going to have a problem. And then maybe I have to do something like X, Y, Z, like a box, and then to put a color as a Y. So maybe. But if I would like to illustrate four features, well,
You can have one of them be a different sound than the other. Play the sound.
it's going to be a
Is it possible?
problem. Yes, thousands.
Are they able to graph it from that?
They're not. We are not going to graph it. We are just going to use it mathematically. Okay?
שלום.
שלום.
ביררנו לגבי הסאונד, שאתה ביקשת שישמעו אותך דרך המחשב הנייד.
כן, מה שקורה.
אוקיי. המצלמה יכולה מצלמת, ומה ששומעים אותך זה...
לאט עשיתי ספוטלייט. אם אני לא עושה ספוטלייט, זום עובד בצורה, כשאני מדבר, המצלמה הולכת אליי. ולכן אני צריך לעשות ספוטלייט או פין, לא משנה, ולשכנע אותו להראות בהקלטה את זה. כי מה שקרה פעם הקודמת,
אבל אתה עושה שר, הוא לא צריך לראות את זה.
לא, אשר למסך הזה.
הוא כרגע...
אוקיי, בסדר, אין בעיה.
אני צריך לפתור פה 4 דברים, נכון? אני צריך וידאו, וויס, שר ופנופטור.
אוקיי.
אז השאר מגיע מפה, הוויס מגיע מפה, המצלמה מגיעה מפה, ופנופטור, לפחות לפי דעתה, הוא מגיע מפה. אנחנו נראה.
זה נכון.
בסדר? אמרתי, אני לא בטוח, כי בגלל הכוחות.
אבל הרקורד נעשה פה. ההקלטה נעשית פה, אתה רואה, ברקורד.
פעם הקודמת, מה שהוא אמר לי לעשות, הוא להיכנס גם פה וגם פה מהמודל. ואז מה שקרה בפועל, שההקלטה נעשתה כנראה מפה, כי נכנסתי שני.
אוקיי, אז עכשיו, אבל עכשיו עשיתם קו-הוסט, זה קו-הוסט.
זה קורסט.
כן.
זאת אומרת שההקלטה היא מכאן, כי זה הוסט. זה הראשי.
כן.
אני הפעם התנסיתי בקורסט, אני מאמין לכם. אני רציתי לעשות ג'וין רגיל, לא קורסט.
לא משנה, זה אותו דבר.
לא.
אבל הקו-הוסט, אתה עושה ג'וין רגיל? לא, אתה עושה ג'וין רגיל, ואז אתה הופך לקו-הוסט.
אתה עושה ג'וי, אתה מצטרף כסטודנט. אוקיי? פה הצטרפת כסטודנט. יפה. ראשי זה שם. עכשיו מה שקורה במחשב הראשי, נתת אפשרות קו-הוסט.
בשביל לאפשר.
ההרשאות
שהייתי עושה, כל מה שהייתי עושה זה רק share possibilities, ואז הייתי יותר רגוע, ואני זרמתי.
בסדר, זה אותו דבר.
אם זה אותו דבר, אין לי שום בעיה.
אם אתה עושה ג'וין ואתה עושה share אחרי זה.
עכשיו, יש לי בעיה אחרת, דרך אגב.
אם הוא עושה ג'וין, רגע, אם הוא עושה ג'וין, הוא עושה שהוא צריך לעשות אפשרות share של כולם, כי הוא לא יכול, כי זה הוסט, והוא לא. אתה צריך לתת את האפשרות שיש share לכולם. בסדר, אוקיי, זה אותו דבר. פה עשית קוסט, אז חסכנו לך את השאר הזה, זה הכל.
השאלה היא מיקרופון. אני לא יודע, אמרתי לך שאני לא יודע מאיפה, אם העברת אותו למיקרופון, השאלה איזה נכון.
למה?
זה מה שאתה יודע.
מקליטים אותך מפה.
לא, פה.
המצלמה מקושרת אך ורק לפה.
נכון, מצלמה כרגע רק מקליטה את הוידאו.
מה שהוא עשה, הוא עשה אך ורק מצלמה.
כי אני אגיד לך מה, אם אני אעביר את זה הפוך, יש לי פה אקו, כי זה לא יודע לעשות וויס קאנסלינג. אז יש לי אקו מטורף.
אז תוריד את זה מפה.
אבל אז אם אני משדר, זה מה שעשיתי משבוע שעבר, ואז שאני מסדר מפה סרט, לא שומעים את הוויס, כי אני משדר אותו מפה.
עוד פעם, אם אתה
לא,
משדר
אבל
פה
סרט
סרט,
כן
אז מה?
הצלחנו.
אם אני עושה מיוט פה, אז
לא.
אני שידרתי סרט, לא היה voice לסרט.
אנחנו כן
לא, עשית מיוט למיקרופון, לא, אני בדקתי את זה.
לא, עשיתי מיוט
בדקנו
לרמקול, הוא עשה לי מיוט לרמקולים, כי מה
לא.
שקרה, הרמקולים של פה
כן.
שידרו את השיחה, נכון? ואז זה קלט והיה אקו מטורף. ממש קרה. אתם מוזמנים לעשות את זה עוד פעם. אבל השנייה, יש לי עוד בעיה. הדבר הזה כל כמה זמן המנורה שלה נשפץ.
למה?
של המקרה.
כן, כל הזמן, כאילו זה ממש מרגיז. חיברנו את המגעים, ניסינו לחזק, אבל עדיין קורה מדי פעם. עכשיו, שוב, הוויס שלנו כרגע השתיק אותו, זה לא מה שאני רוצה שיקרה, כי אני צריך בסוף שהוויס שלנו.
ירון לבדוק. כל עכשיו הבאתי אותה לפה, באב הבית, שהוא יעשה משהו, אבל הוא אמר, נכון לעכשיו אני לא יכול לעשות.
עכשיו אשתי, בסדר.
כן, הוא אשתי. אבל ביקשתי ממנו שיטפל בזה. הוא אמר שכן, הוא יטפל בזה.
אני אומר, פה, אני לא יודע למה, מדי פעם זה מתנתק.
יכול להיות שצריך להחליט פה זה, כבל. אני אביא לך כבל.
אולי נסתם מהבא של מגעים, אני לא יודע. גם אני לא התלוננתי, כמו שנאזור היה זה גם, היה לי ככה, לא התלוננתי. עכשיו כשאתם פה, אני מכיר.
זה שלפניו, עובד על זה.
כן.
לא יודע.
זה לא מקרה, זה לא מקרה, זה
כבל. זה הכבל.
יכול להיות. בסדר, אני צריך להמשיך.
אני אראה לכם,
אם הכל בסדר, הכל בסדר. אבל אם אני טוב לך, שמה שאני...
כן, תכתוב שעות. תודה רבה.
Okay, let's continue. The next possible way to go and to classify is a different one. And this is called using local information and not global information. Meaning, the concept is, if I need to classify this point, again, this is feature 1, this is feature 2, okay? The points are located by the two features. And again, Y, the label, is given by the color and shape. Okay? So I have here class 1, class 2, class 3. And now the question is, I need to classify this point. Okay? So the third method, and I told you the one method was, and the second method is, recall I can draw line, right? The third method means, no, I'm not going to draw line. I'm going to ask myself, let's look at my nearest neighbors. And I'm going to say that if I look like, or if most of my neighbors are from one type, then probably I belong to them. Okay? For instance, why it's called, this is method, it's called K nearest neighbor. K stands for a number. So if I use K equal 9, I'm going to look at my 9 nearest neighbors, and then I notice that I have 4 squares, 3 dots, 2 rectangles, so probably this belongs to you. Okay? Because these are 4, this is the majority.
Can you explain again, please?
Yes, in this case, I'm not going to look at everything and try to do some kind of measurement. No, I'm going to look right, left, etc. And who are my nearest neighbors? And if I see, in this case, I'm asking for 9 neighbors, I'm going to count who are my 9 nearest neighbors, and the majority are rectangles, I'm a rectangle. Okay?
So it's not the distance, it's the number of...
Yes. Yes, because if I'm going to set K for instance to 3, then these are my nearest 3 neighbors. And in this case, well, I'm a black dot. So you can see that if I'm going to change the number K, I'm going to affect the results. Okay? Again, there is a guy that developed a very nice website. So this is, you can see the number of neighbors, okay? I can start by putting the examples. Let's say I have now 50 examples. And now I'm looking for my nearest, let's say, 3 neighbors. So this is the classification. You see, again, it's colored by regions. By the way, if it's white, the algorithm can tell. Okay? If I'm going to say, let's say I'm going to look for 5, then I'm going to get a different result. By the way, notice here, because there is one blue here, so this region is red, although it's in the blue region. Okay? And if I try to look for 3 classes, then I'm going to get a different result. Now let's say 30 points. And I'm going now to say 3 nearest neighbors. It change, all the time it change. Okay? So this is the problem, which I'm going to speak about in a minute, that you need to know what is the best K to choose and how.
The white area.
The white area is an area that the algorithm can tell. Because if I look for 3 very close neighbors in this region, I can going to count and I'm not going to get a conclusion. So I don't know.
This example, so each color is the sample, right?
These are the samples, the dots are the samples, and the region is the class. Meaning that if now you will ask me what is happening here, I don't have a sample here, right? I'm going to say, well, it's red, so red. Okay? So I use those examples to say that everything here is red.
Based on the K.
Based on those samples and the K labels. Okay? In this region, if I'm going to look for the 3 nearest neighbors, let's see. Probably this one, that one, and that one, right? So the 3 nearest are red. This is red. Okay? More questions?
What if there's no majority? Like, all the numbers are the same.
Then you're going to have a problem. And this is why you see the white areas. Okay? Because if I'm going to look here, for instance, then probably if I look for 3, 1, 2, 3, I don't know. Okay?
Can you then just change the K so it's the 4 nearest neighbors?
Let's see. Let's change it to K, to 4, okay? I'm just clicking here, see? Even worse. Okay? And if I'm going to say only 2, and this is 6, different. Okay? And it's very easy method because all you need to know is just look around, count for the number of neighbors, and decide. But it's very difficult to set how many neighbors I need to look for. I don't know.
Does each method depend on the size of the sample? Okay.
Sample set. No, because there are methods that are better with large numbers and small numbers, but it doesn't depend on the number. Okay? Why it's working? Okay, so K-nearest neighbors is pretty intuitive. All I need to know is just look around. I don't care about everything that happens beyond. And there is few parameters to tune, well, only one, the K. But this is a con. I need to know the value of K, and I have no idea how. Also, it needs something which is called a homogeneous feature set. I'm going to discuss this later on. And it's also sensitive to noisy or irrelevant feature, which I'm not going to get into. To sum up, I showed you now 4 different approaches to try to classify. One of them, 3. One of them is by approximating, which is basically the regression. Second one is by separating, and this was the SVM. And the third one was by closeness, and this was the K-means methods. Now, there are many others. There are hundreds of methods. Of course, I just gave you 3, and I'm going to give you 2 more soon. But for now, let's stop here and say that all of them, all of these methods that I already showed you, have a hidden assumption, which is called continuity. What does this mean? If I go back to this slide, I have only one feature, and here is the label. And I told you that I can draw this line as a model. The question should be asked, can I do it? Because let's say I have some region that something is not defined here. If you recall from math, from your high school, there are cases that you cannot use math. For instance, I cannot divide by 0. Or I cannot have a square root of a negative number. So those are regions that I don't know what is going on there because it's not defined. So let's say I have some region like this, and I have a sample sits here. So if it's not defined, I cannot just draw a line. It has no meaning. I'm not going to get into the whole mathematical theory here, but the basic idea is that all those 3 methods assume that I can do this, but there are cases that I cannot. So what happens there? And basically, it's not so far-fetched because let's look at a numeric feature like number of legs. There are animals with 2 legs, 4 legs, 6 legs, 8 legs, but there are no animals with 5 legs. So it's not continuous. I cannot just assume that I can draw a line. Okay? After I showed you a spider, then I showed you this cute dog. So this is an animal with 3 legs, but this is not what I mean, okay? So basically, even if you have a numeric feature, it doesn't mean that you can use any number. So you cannot just draw lines between the numbers. It doesn't make sense. Questions? So all those methods are not valid in cases that you cannot be sure that you are able to draw those lines. And this is also true if you have labels which are not continuous, which are discrete. For instance, apple, not apple. Okay? Like in this case, you have samples, and the answer is either yes, apple, or no, not apple. So how can I draw a line? Because there is nothing in between. I cannot draw lines. And if I'm going now to ask about this point, I cannot draw a line, build a model, and do something. Doesn't make sense because it's either yes or not. Do you understand?
I decided it's yes or no.
Yes, but there is nothing in between. If I would like now to draw a line, meaning that I'm saying something about what happens here, but there is a void here. It's either yes or no. Okay, it's discrete. For instance, another feature, gender. There are no so many genders, right? It's discrete. So you cannot draw lines and assume there is half men, half women. That makes sense, okay? So there is now a different way to go, and this is called decision trees, okay? Decision tree is a different method, and the idea here is we are going to break the data sets by a series of questions. And each question we are going to say yes and no until it is narrowed enough to make a decision, okay? And this is going to be based on the feature of the training set, okay? And I think it's better, I'm going to start with the example and then go back. Let's say now I'm a bank and I would like to decide whether to approve a loan or not, okay? So I'm going to use questions, and those questions are represented here. There are 5 of them. And based on the samples of people who returned their loans and those that defaulted, meaning didn't return their loan, I noticed that the first question I need to ask is, what is your credit history? If it's bad, then I'm going to stop here. I'm not going to grant. If it's good, I'm going to ask a different question about age. Now, if you are in middle age, I'm going to ask about the income. If you are youth or senior, I'm not going to grant. If your income is low, I'm going to look at your properties. If your income is medium high, I'm going to look at your employment length, because if you were just hired, doesn't guarantee to me anything, okay? You see what I mean? This is a decision tree. Here, I don't need to draw lines. I just need to ask and get answered here, yes or no, or like this, low, medium, high. So in this case, I can build a classification, in this case, classification tree, that I just going to divide the groups until I get an answer, okay? And this is not, I'm not assuming that this is just for illustration. I don't know if banks actually works like this, but you know, it's better to be rich and healthy than poor and sick. So it's you can see it. Now, again, let's go back first. Sorry. I use the example, and for each of those, I use the feature that is most effectively splits the training set into subset, enrich in a specific class. This is how I'm going to choose the questions. And again, there is a website that tries to demonstrate this. Again, with numbers, because it's very hard to demonstrate things like poor or middle age, right? So I'm going to use, again, number. So what I'm going to do again, I'm going to pick blue examples and red and blue. And now I'm going to ask for tree classified. So I get this result. What does it mean? Here I have 23 examples, okay? I don't know anything about it. But I know that in this box, I can decide, because I have only 2 examples. Both of them are red. So everything here I define as red. Okay? Now let's go here. There are 21 examples here. This is this box. Okay? I have here both red and blue, right? So I need another question. So I know that this region is only red, but this region has both. So I'm going to ask another question. Here I have only blue. Here again, I have both blue and red. Here I have only blue. Here, well, I have a problem. Maybe I can continue and split it, right? See what I mean? If I add more points, for instance, let's add more points. You see that now I get a different result. Let's add more blues. I get a different result. Okay. Now this is about the depth of the tree. I can also decide what is going to be the depth, how much I'm going to continue to split it, and I need to tune it. Okay.
Split it into 13, then you will not have a problem.
Hmm?
If you will split it into 30,
Because I have 30 examples, right? Yes.
but then any circle.
But probably I'm going to get a very poor result later on when I'm going to test it, right?
Yes.
Okay, let's continue. So it's quite simple to understand this method, because basically it mirrors our decisions. Many times when humans try to take a decision, they use this method. They are doing those trees. It's very common in many sciences. It's able to handle both numerical and categorical, meaning yes, no data. Doesn't care.
Random forest. Isn't that a random forest?
One slide, please. It performs well with large data set. Okay, so those are the pros. What are the cons? There is an issue of overfitting, which I'm going to get back later in this session. It might be non-robust, meaning small changes in the training set might result in a large changes. If you recall, when I just click more few examples, you see that everything changed. This is this point. And furthermore, sometimes it may depend on the examples that I'm going to choose. If you recall, I need to put some of the examples for testing, put aside. So it may be that when I divide those examples, I'm going to get different trees. This is what's happening. So one way to deal with this is to use the method which is called random forest. What is random forest? It's taking many trees and each time building the tree on a subset of the examples. Okay? So I'm going to build many of them. And then instead of asking the tree for answer, I'm asking to ask all the trees for answers. So let's say this is going to say A, this is going to say B, this is going to say B, and also there are many in the middle. And then I'm going to do a majority voting. This is more robust. Why? Because I'm not influenced by specific examples or by outliers. Because if one tree was built wrong because some outlier, the others are not. Okay? So the method of random forest is built on the method of decision tree. Take several decision trees.
How many trees? And
More the merrier. Okay?
It's unlimited trees, right? You can do as much as you can.
Yes, but you have also performance issues. You don't want to run forever. You need to bring in answers sometimes. So you need to balance. Questions? The last method which I'm going to mention, but I'm not going to explain now, is called artificial neural networks, or ANNs. And basically nowadays, the two methods that are most used are the random trees and this method. And this I'm going to teach in either later today if I have time. If not, this is next lesson. Questions? Okay, I'm going to say now a few words about predictive analytics because many times people are using classification for predictive analytics. And the idea in predictive analytics is to analyze historical data in order to make prediction about future events. Now, I already mentioned an example for this when I spoke about the loans, because this is exactly this. I tried to take historical data of loans and try to use it to predict whether a new loan is going to default or not. This is exactly prediction. Okay, now it's the same thing like classifying whether this person is going to return or not. But in this case, since I'm going to classify about the future, people are going to call it predicting. The same thing. So leading prediction techniques use the classification method, which I just show you. Training data set contain real examples with known outcome. There are also some unsupervised learning methods for prediction, which I'm going to discuss later on in the course. But basically, the main tool for prediction is classification. Applications for this are underwriting and loans, which I just demonstrated, try to mitigate future risks for default. Fraud detection, try to get an idea whether a new insurance claim is fraud or not, fraudulent or not. Again, I'm going to use previous insurance claim try to learn from them, and then try to classify for new claims. Whatever entertainment medias are doing, like Netflix, etc., they are trying to use previous history data for people what they wanted to watch, and try to deduce from this which movie to predict to you. And this happens again and again in retail. The issue of cross-sale. You know, in Amazon and other sites, people who bought this product also bought that product. Again, trying to predict what are going to be your preferences based on preferences of previous purchases. Customer retention, we are trying to understand the churn of those customers who would like to leave the company using historical data, trying to predict who is going to leave us and try to offer him or her something to make them stay. Direct marketing, meaning, well, I'm going to try to market a specific group based on historical data of similar people, etc., etc. And there are many more examples. Questions?
Is the instant algorithm local?
Sorry? I didn't hear.
You know, like TikTok algorithm and like the social media algorithms that we talk about?
About what?
That like that pushes up content that either like going viral or
No, that's different. If they're about your screen, meaning to make sure that you're trying to get the best article or whatever that suits you, it's exactly the same like Netflix, right? Try to predict what is going to be what are your interests. Same thing. If we are talking about other algorithm, meaning what is going to be viral, this is different.
so they're not using predictive.
No, they are using predictive analytics for your feed, but not necessarily for what is going to be viral. This is a different question which I'm going to talk about later on. Thanks. There are limitations to try to use predictive analytics. It happens to be that it's much easier to predict the past than predicting the future, unfortunately. And the reason for this is that all prediction methods are based on past experience, okay? Either supervised or not. And if you use classification, you need previous examples, okay? Surprising events have no previous similar events, like 9/11. There was nothing similar, never. So try to think, I can build a predictive analytics to predict 9/11 or COVID-19. It's stupid because there is no previous examples for this. So how can I predict it if there is no precedence? You see what I mean? It works well when there are many examples, like in loans or insurance or Netflix, but luckily enough, we don't have many 9/11, so. And the same thing happens in election campaigns. And even in Israel, we have many of them, unfortunately, they are very, very different from each other. I'm going to go speak about this later in the course. And those election polls, said people that I use those are for shows that are not really science, just for show. Questions? Okay, so now let's talk about challenges in classification and what would be their solutions. I take you back to this slide that I showed last week. If you recall, you first need to understand what is your question, then you need to understand your data. Sometimes you go back because you don't have the right data. Then you have to do some operation to prepare your data, clean data, fix it, etc. A lot of stuff which is for me boring, which I'm not going to teach you. Then you try to model what I just demonstrated to you, and you evaluate it. And many times, once you evaluate it, you go back to scale one because that's work. And I'm going to speak about how to evaluate later on. But sometimes you cannot even model because the data is not good enough in order to model. Okay? So this happens, and this happens again and again in many, many projects. And I'm going to try to give you now some ideas why. What are the challenges? Why this is failing? So I'm going to cover 5 challenges. One of them is building your training sets. Then I mentioned several times the issue of overfitting. So I'm going to introduce what is overfitting and how to try to avoid it. I'm going to speak about feature engineering. I'm going to speak also about the problem itself. When you have spacing variance and also overlapping classes. So let's start. Many samples are needed, as I said before, if you would like to get a good classification result. And you need it for each class. If you are doing only binary classification, then you have 2 classes. If you are doing multi-class, like in the example of animals, then you need many examples for each class. And many is many, okay? It's not easy to collect those examples in many cases. Furthermore, it's not easy to label them, okay? For instance, I spoke before about the insurance claims. How can I tell if past insurance claims are fraudulent? Unless they were convicted in court, how can I tell? Can I be sure? And vice versa. Maybe I approved the claim and it was a fraud. I didn't figure out. So now I use those past experience, so maybe it was wrong, as labels to learn. But maybe I was wrong before. Okay? There is in computer science, there is something which is called GIGO, garbage in, garbage out. So if I have bad data, how can I expect good outcome? Okay, so labeling is not always easy because in many cases, it's not certain. We don't really know. Sometimes it is not available. For instance, when we try to do it in cyber protection, it may take a lot of time and tremendous manual effort trying to label, for instance, network traffic. Try to mention which traffic was malicious, which is not. It means that I need now to go over huge volume of traffic and label them. It's a huge task. And sometimes I cannot do it because of legal issues, privacy issues, confidentiality issues. I cannot even look at the information. So I cannot label it. I'm going to talk about privacy by the end of this course, but for now, I hope you understand that I cannot just look. For instance, I would like now to do something about spam mails. So I need to read mails of people. This is not so easy, right? Questions in now? So there are challenges to collect the data. Even if I have data, I need to ask myself, is it really representing the space or the problem, this problem space? Let's look at this as an illustration. You are now detectives, and your mission is to identify 2 male suspects wearing blue jeans. Okay? In this case, well, it's not very hard. Okay? So now let's say we are taking those samples. Those are bad suspects, all the rest are good. Okay, and we are now going to train them. We are going to collect more suspects, and we have those as the non-malicious, meaning benign. So we are going to train it, and we are going to test it. And believe me, we are going to get wonderful results. However, after we build the model, now we try to use it in further investigations. And let's say now you need to do the same task to spot those two suspects. Well, what is going on? The suspects are still here, in the same place. But the innocent people are different. Okay? Because before, all innocent people are women. Here are men. So actually, I didn't learn to classify between bad guys and good guys. I learned to classify between men and women. Now, this is, of course, artificial because I make it for the class. But if you think it's only on the class, well, no. Let's go for two examples for real world. One of them, again, is from the world of cyber. Let's say we have binary files, and we also have malwares, binary files which are malicious. Okay? So I would like now to produce a classification model that will get a binary file, and we classify it to malicious or benign. Okay? So again, I need to collect examples. Here I put the labels, those are benign, those are malicious. I'm going to train one of the algorithms that I showed you. I'm going to get a model, and it should work, right? Well, wrong, because many times people collect benign files from their computers that they have. And if you look at your computer, thinking that you are using a PC, most of your files produced by Microsoft. So actually what you learned is to classify between Microsoft and non-Microsoft. Or if you use Apple, the same thing what it happened. And now this is not artificial. I saw this in real life. People did and got great results. But then when they tried it in the field, it was total failure because they didn't learn to classify malicious files. Questions? Same story in health. This is from Scientific America. The story goes like this. This is a chest X-ray, and the idea was to predict which patients in hospitals are at risk to get pneumonia, okay? They made an AI system, and in the hospital, New York's Mount Sinai, a very loud one, it worked fantastically, okay? They get very good predictions. So other hospitals heard about it and tried it, and it flopped. Why? Because I'm going to move to the next slide soon. Because what happens to be they collected X-rays examples from two machines they didn't know. Okay, the computer actually learned to tell the difference between what is called portable X-ray and images from the radiology department. Okay, now as you can imagine, portable X-rays are taken for people that cannot get up from their bed, right? This is why they are bringing the portable machine. All others walk to the department, okay? Portable machines are usually used for patients too sick to leave their room. Not surprisingly, that this patient had a greater risk of pneumonia. So actually what the algorithm learned is not to find out who get pneumonia or not, but two machines. The images look different. Okay? So even if you are collecting samples, you need to think, is it a good representation of what you are going to do later on? And if you are collecting samples from two different machines, you need to do something to make this disappear, this distinguish between the machines. Otherwise, the algorithm will learn this and not your goal.
It's the distinguish between the machines, or we learn to say whether there is a cancer, there is a problem in a place, there is a problem,
No.
and where the place there is no problem was not.
Distinguish between the machine. This is why when they took it to other hospitals that have machines from other vendors, it flopped.
But it's also can be that the test sample beside the machines was two sick people, and then the system learned to identify something that exists only.
No, if it was the case, then it will succeed on other hospitals.
Depends on the population that it's tested on.
No. Sick people are the same sick people in all hospitals. Let's assume this.
Yeah, take a sample test of 90% sick and 10%.
I don't know. This is another question, but I tell you that you can read the article from Scientific American. I think I put here the. If not, it's very easy to look for it. This was the problem. Okay, so to summarize this part, it's not easy to collect examples. Sometimes you have a tremendous issue of hard work, sometimes legal, etc. Sometimes you think you collected the right examples, but they are not good representation. It's not an easy task. And this is why many projects are failing. I'm going to return to this when I'm going to discuss. There are nowadays debates whether AI is racist. Okay, so I'm going to get back to this issue. AI is not racist, but people are stupid doing stupid mistakes. Okay, more questions? Let's take 10 more minutes break. Let's start at 5 and 10 minutes, a bit more.
היי, מה קורה?
כן.
רציתי לשאול על לעשות סמינר בקורס. פשוט הייתי בגלל שבוע שעבר, אנחנו מחכים, אבל כאילו, הייתי במצגת, כאילו...
יש אופציה כזאת.
כן, יש אופציה ב-12 מאמרים, אבל כאילו, באיזה נושאים...
הנחיות. אני היום, אני מניח שישאר לי זמן, ואז אני לא אתחיל נושא חדש, אלא אני אעבור על ההנחיות. כן? כן, אנשים בדרך כלל שואלים, אז אני מעדיף כבר לעבור על זה.
כן. עכשיו בא, כן, זה לא רגיל.
Everyone, chair. Of course.
And all the sounds. Natural. You know, it's the last national going on. When else is? Maybe is it with them? Maybe with it. But you go. Yeah. Okay, I think you will maybe family. Well, this spot is even on the church. Every time it's like that. This is very. I was over. I speak information with that. Well, I must say that really yes, it's really mission to be like that. And we got even 2 years of school to be. Well. Yeah. So, nothing wrong. Nothing. I want to know. Yeah. Well, you should be around people here. You. So it's fine. Okay. What will you do? I'll make sure that getting everybody thoughts. I do that about them. What doesn't let myself? Good feeling with and with what we do every night. It's not myself. We should be out.
Okay. The next issue, which I'm going to speak about, is overfitting, which, as I said, I mentioned several times. If I would like to improve a model, what usually I can do, again, this is the model. I can try to add more points. And now I have more information on what is going on between my examples. So I can improve my model. Okay? Now, this is better, but there is a risk here, which is a risk of overfitting. And what does it mean to overfit? Let's say those are my examples. Okay, this is picture, only one, and this is the label, the Y. So now I would like to build a model using linear pieces, so I can do something like this. As you can see, I have a great model. No deviation, no errors, perfect. Okay? However, let's say that I now collected more samples. I was able to collect more samples. And now I have new samples, those yellow ones, or whatever. And now I can notice that something else is going on here. It seems to be this drawing this regression line is better than the one I had before. Why? Because this line was overfitted to the examples that I had at that time. So I tried to make it perfect for them. But it happens to be that those set of examples that I got to manage to collect before are not representing the whole story. There are more examples that happens in other places. So if I'm going to be exact on the examples that I have now, I'm going to make mistakes, because I recall my goal here is not only to try to be exact on the examples, but to predict what happens on the sides. So this model, for instance, had very bad prediction for those two than this model. This is probably an outlier, also this. I didn't know this before. You see, the problem is that I can't tell always what are outliers. It's not an easy task. Okay? So one solution for this is collect more examples. If you get more and more examples, then you might or may avoid those issues, because you have better representation of everything that you'd like to classify. Okay? Another way to go is not only to get more examples, but to add more features. Those two I'm going to get back and explain them in more depth later in the course. Another way to go, which I'm going to mention now, is what is called, to try to avoid this phenomena of overfitting, is cross-validation. If you recall, I told you that I need to split the examples between those that I use for training and those that I'm going to use for testing. But I can do better. I can split again and again and again. Okay, I'm going to take those for testing, and now this for testing, and now this for testing. Okay, I can do it many times. Usually it's done 10 times. So 10 times I split again the group, some of it for learning, the rest for testing.
Create a few models?
Yes, yes. This is called cross-validation. Now, this is very similar to what I explained about the random forest. If you recall, I built different trees. Each time I took a different sample from the examples and built a different tree. So this is very similar idea here. Each time I'm learning from different sets and testing by different sets. This way I can make sure that I'm not overfitting to some specific examples. I get more generalized case. Questions? Now, there are other methods which I'm going to explain later in the course, but the basic idea is to try to avoid this problem of overfitting. You need to do something about it, and this is one way to go. Next, I'm going to speak about how to select the features that you would like to represent each of the objects. Back to the illustrated example that I gave you before. Here, I told you that you need to look for male wearing blue jeans. So basically, I have two features. One of them is gender. The second one is pants. Okay? In this case, it works fine, right? Because there are only two males. So this is a feature that is actually good for differentiate between the groups. If I'm going to use this group, well, those two features don't really do anything. And again, I'm looking for those two guys, right? Because almost everyone is wearing blue jeans and all of them are male. So those features are useless if I'm going to try to differentiate between those two and the rest. See? So I need to engineer other. Let's say here, again, it's of course, it's synthetic. Let's say I'm going now to look for shirt color, the posture, and the hair. Okay? So shirt color, I'm looking for people with green color. So I have also these and that. Okay? Not so good. Posture, upright standing. So I get rid of this. And hair should be short. So I get rid of this. Okay? Of course, this is very a synthetic example, but this is actually working in real life. If you like to get to describe the object, it's better usually to take more features because you cannot tell in advance which features are going to be descriptive. Okay? Questions? Also, one needs to decide about the metrics, how to know which is close and which is far. If we are speaking about numbers or continuous numbers like age or height, quite easy, just measure. But if you are talking about categorical feature, we cannot speak about distance. So it's either or. Again, you cannot draw lines between them. So you cannot use methods that are good for numbers. You need to use methods that know to handle categoric features. And also, let's say we need to do something about colors. So how can I represent colors? So for this, there is a solution. In the computer, you can have color range by numbers. We're going to speak about it when I'm going to speak about images. So again, I need to find some way to say that, let's say that green is closer to blue than to dark red. I need some way to tell it. Okay? And when we are going to speak about text, how can I say which word is apart from other words? I need to measure it, right? So one way that now text is working well, text analytics, is because people crafted a way to measure it. And I'm going to speak about it when we are going to speak about text. Questions? Next, a challenge that I'm going to speak about is space variance. Space variance meaning you need to consider how a variable, how variance is your space. If it's a high variance, for instance, in this case, there are many, many different shapes or colors, then it's going to be difficult to collect examples and to make sure that you know to differentiate between the samples. Let's say we have a very, very simple world. Two types of object, either blue or red. So in this case, it's very easy to collect examples and to differentiate between them. Actually, I need only two examples, right? One blue, one red, that's it. This is very, very easy. If I have two types, but many shades, it's harder. But still, I can, because all my world is either bluish or reddish, I need to collect more examples of what are bluish and what are reddish. Okay, because of course there are many, many types of shades. But still, since it's either this or that, it's easy. Okay, I cannot do real mistakes. The problem is that in many, many interesting classification or prediction problems, we have high variance or colorful. So now let's say I would like now to differentiate between more bluish and more reddish. But there are some points here which are neither blue nor red. What I'm going to do now. For sure, I need to collect more examples. And also, I need to find a way to deal with those that are not blue and not red, because they are going to make problem. Okay, I'm going to mention this later on. Now, it looks artificial, but it's not. Think about what I told you before about malicious files, cyber. There are benign files, but there are different types of benign files, and there are different types of malicious files. Some of them, let's say, are ransomwares, which try to shout, please give me money. Some of them try to be very, very silent. They want to steal data. They do not behave the same. So if you consider the word as benign, malicious, you are wrong. This is not the case, because they are different. Okay, they are different shades. This is why many, many antivirus applications fail, because they didn't realize that they need to do multitask classification. More questions? The last thing that I'm going to speak about is overlapping classes. Go back to the SVM. If you recall, the task was to draw a line that separates between the groups. So it was quite easy in this case, but it's harder in that one. If you recall, I showed you this on live. Let's do it again. So if I have only red here, sorry, I need to stop again. Red here, blue there, then it's going to be very easy. But if I'm going have also blue here, I have problems. Okay? So this is the issue. For instance, let's say I would like to classify all objects on the world to 3 different groups, either long items, round items, or floral items. Why? Because I need an example. Okay? So in this case, I need to collect examples. So these are long items, these are round items, and these are flora. And as I told you, sometimes, sorry, a cabbage is the problem. Because what I'm going to do now, where should I put it? It's both round and flora. Okay? So this is again artificial. But let's now try to consider a real world application which is trying to classify person political leaning according to his post. People are doing it, okay, around the world, trying to approach on Facebook, etc., and try to approach crowds, and they try to classify what is the political leaning of a people according to its posts. Okay, so many times at least in Israel, you cannot actually set apart different parties because we have many of them and there are a lot of overlaps. Okay, So this happens in real world application. This is one example, but it also in others. Questions?
Wait, like you said post?
Hmm?
Oh, you said post, like social media post? Or what?
Yeah.
Alright.
Perfect.
Like, you can just weigh specific phrases or words.
I'm looking at the post, I'm analyzing it,
Yeah.
try to classify whether, let's say, it's a right-wing person or a left-wing person.
Yeah, so you can weigh like in regards to the outlook. Is that what they do?
No, I'm trying, I told you that at least in Israel, we have many parties. So trying to do it, I not always can tell exactly which is which. Okay, I can see one post and I have several options to put it. By the way, another illustrative example is recycling. I have plastic recycling, carton recycling. So what I'm going to do with this? Okay. By the way, they started to put the color on the box to make sure that people will know what to do with the can. So what can I do here? The idea is that it might result in problematic classification or incorrect one. And one solution is to add more features, so maybe I can tell apart. Other solution, and people are many times choose this solution, is to add another class, which is called unknown or other. Meaning, if I don't know to tell apart, then just let's throw it to the other. Okay?
Well, what is so wrong with an item that is belong to two groups?
Hmm?
What is so wrong with an item that belong to two groups?
Because
That's a wrong
the whole
situation.
idea is classified. You need to put it either here or
Yeah,
there.
but I'm saying that the question where you put it both here and here is also valid
No,
situation.
no. Let's continue with the political example that I gave you. Okay. I now would like to know what are, let's say, the sentiment of supporters of a specific party to some issue.
But then,
I want to make sure that I'm looking only on people that are really supporters of this party. So I don't want to look at others. So in this case, I prefer purity, meaning get rid of others because I have enough people. So this I'm going to do the other. I'm going to throw everyone other places to make sure that all those that I classify are really supporters of this party.
yeah, I understand. But in this case, you can also do in hard support or soft support, like 1, 2, 3,
This is
4,
another
5.
way to go. Yes.
But I agree with you in this case. But in other scenario, when you try to, I don't know, to the cabbage example. So what's wrong with cabbage being in both groups?
This is artificial, of course. Okay. Now,
The more picture, meaning class has more than one picture.
no. For each object, I'm going to collect more pictures that describe it.
But let's look at the cabbage. For a picture, it's a
Maybe if it's soft or not. Okay, this is artificial. In the cabbage case, this is not a solution. Okay.
Then you can
By the way, I cannot always do it. Let's say now I'm an autonomous car and I'm driving. So I need to classify each object I see, whether this is a pedestrian or a car or a bicycle, etc. I cannot do other because, again, I'm going to run over it. So this is not always a solution. I need to give some answer. And we'll see that this is problematic when I'm going to speak about adversarial AI, how to fake AI. You'll see that this is the real issue.
Yeah, but in this example, for example, just get for the car, for the autonomous car, I can say that I should distinguish between two groups.
Okay.
A large item that I should not go into, and a small item that I can go over. That's it.
Oh.
And then a bike, a tree,
No.
a stone will be the same.
Few years ago, there was an issue that autonomous car, I don't recall of which company, ran over a lady that was walking a bicycle across the road. This is exactly the issue. Maybe the car thought that this is a bicycle, so the velocity is different. So if it is a bicycle, while I'm driving, when I'm going to get there, it's going to move, right?
Okay.
But it was a woman walking a bicycle, and it ran over her. So it's an issue. We don't want autonomous car to run over people. At least not me.
No, I'm following what you say. This is a
This is a real issue. It's a real issue.
This is a valid
Sometimes you can say, I don't care, but I tell you that there are cases that you really care. Okay? Questions? So, in the case of the cabbage, if I put it in the other, everything is okay. I have pure groups and problematic ones. Okay? It also solved the issue of high variance, which I mentioned before, that I told you that they are colorful. So again, I look at these high variance groups, and I have a group of reddish, a group of bluish, and a group of others. And it's solving. If I can do it, it's very good. As I told you, not always this is possible. And by the way, this is the choice of recycling. Okay, this is the other thing. Exactly. Okay.
long as not everything goes into the other.
Questions?
What happened in Israel in the cycle?
Okay, so I'm not going to start a new topic today. What I would like to do now in the few minutes that we left to go over for the first time on the homework, because several people already asked me. I'm going to go over it several more times, at least 2 more times during this semester, but let's do it for the first time now.
Final exam?
Okay.
Yes,
Why?
it's not an exam, it's a home. No, it's not an exam. It's a home assignment. Okay.
Let's do a semi.
Why it's doing this? I hope, yes, okay. It seems like now it's okay. Okay, so in this assignment, you are asked to choose a research question relevant to what we learn in class. You should find and analyze 2 to 3 academic articles, okay? Not newspapers, the Jerusalem Post or New York Times are not academics, that are relevant to one of the following topics: the impact of AI on managing bilateral conflicts in the cyber age, the impact of AI on the future of conventional battlefield, implication of AI on citizen-state relations, and the arms race between the powers in the field of AI. Or if you would like, you can ask me to write on other topic. Now, I'm going to cover all those topics in the course, okay? But you may ask me to write on other topics. In the course, we have discussed various techniques of AI or ML. By the way, this is the beginning of the course. I showed you only one technique, classification. That's it. But I just give you, we are going to have more. Alongside their application, for instance, an application for classification is loans. Okay, an application for classification is to classify between different fruits. By the way, this is a real application. If you are going now to supermarkets and you would like to take an autonomous trolley it's called, I think. And then at the end, you need to pay for apples. So there is a classification process there to make sure that you are taking apples, okay? So this is the real application. And analyze at least 3 different AI techniques that have been presented in the course. For example, to refer to the use of 1 technique for the first application and 2 additional techniques for the second application. Clear? The selected application and techniques must be clearly stated at the beginning of your work. This is for my experience from previous semester. If students writes it before, then make sure that it's going to happen afterwards. Afterward, people are just forgetting to do it. You are not expected to draw precise technological conclusion, but to analyze feasibility consideration. I told you today several considerations when it's not going to work. So I not expect you to be experts, but just to say it's going to be difficult to collect examples, for instance. Okay. By the way, I showed you today the algorithms for classification. You are not required to speak about those, just about classification. I don't care which method is used. Okay, you don't need to get to this resolution. Okay, I told you how it's done because I'm teaching you. But when you are going to analyze your work, you just say this is a good case for classification. That's it. In addition, you should discuss the implication of this application on cyber, because we are in cyber program, and different relevant government and political aspects because we are in social science, depending on the topics you have chosen. Okay, and I'm going to speak about those type of implications. I'm going to speak about privacy, about racism, etc., etc. There are several. Questions till now?
Is this, I was looking for it, maybe I just missed it. Is this on our Moodle?
No, I'm going to upload it. Please note that as part of your analysis, you are expected to present your personal views. However, it is important to clearly separate your personal views and article summarization. What is to separate? To say, in my opinion, or I think that, okay? There are guidelines of CPG guidelines for an academic work. I'm going to upload this also. The required scope of work is between 14 and 1600 words. It does not include references. I need the cover page, and the most important thing in the cover page is the word length, and you cannot go beyond the limits, not more and not less. Okay, this is the limits that you need to write. And fonts, and I don't like footnotes. What questions?
Seminar, or is it just?
This is the regular. I'm going to upload the seminar in a minute. Questions now? Okay. So I'm going to upload it to the Moodle this week sometime. But again, it's premature because we just learned one technique. We are going to learn more. And let's see the seminar guidelines. Basically, it is similar, but of course, it's going to be more lengthy. You are asked to choose a research question relevant to what, again, the same thing. And now, in the seminar case, you must approve the topic with me, the research question with me. Homeworks, regular one, you don't need. As long as you fall in one of the buckets that I described, go ahead. For seminar, you must get my permission to write a seminar, and no later than a month before the end of the semester. Okay, it's somewhere in May. I don't recall when, but keep in mind that if you think to write a seminar, then consider it and approach to me no later than by a month before the end of seminar. A good resource question for a seminar is meet the following criteria. It should be an interesting topic, not boring, and you can locate at least 12 academic references to base your work on. As I told you, this is not an easy task, but for AI, it is doable. You can find this. Those of you who can deal with technical paper, for sure. Those who are not, it is challenging, but students in previous semester did it quite well. So it is possible, okay? It's no problem. It falls under the following topics, and those are the same topics that I mentioned before. As I told you, I'm going to cover application for this in my course, and also the arm race between the powers. I'm going to dedicate a few minutes to this also. You have to discuss various techniques of AI alongside their application. This is the same. You are required to refer to all AI applications that appear in the article you have chosen, at least 5, okay? Different application, and to analyze at least 2 relevant AI. So here you don't need 2 applications, but 5, and at least 2 relevant techniques for each of them. There is same, here is, this is the same, exactly same guidelines as I gave you before. And the guidelines of how to write the paper are in the CPG guidelines as before. 2 leading articles, the amount of work is 6,000 to 7,000 words. It's of course a longer paper, and beside this, it is the same. So those who are considering to write a seminar, maybe it's still premature because this is only second session, but let's say that starting from the 6th or 7th session, please consider it and approach me to let me know that you're considering it and to try to run by me your research question. More questions? Now, most of those guidelines are going to be much more clearer in the middle of the course, not now, okay? But I asked, so I gave you a heads up before. So I'm going to upload them, and also I'm going to upload the presentation, and hopefully now we have a good recording, so I'm going to upload it also. Okay, see you next week.
Thank you.